Hello everyone and welcome back to Hope Coaching Institute Private Limited. So today we will be discussing about some important questions of thermodynamics topic. Previously I have taken some questions from P. Bahadur book also, and this is an NCERT question, maybe it is question number 5. So let's take it. The enthalpy of combustion of methane, graphite and dihydrogen at 298 Kelvin are minus 893.3 kilojoule per mole, minus 393.5 and 285.8. So we are asked to find the enthalpy of formation of CH4. So enthalpy of formation of CH4. So firstly we have to write in such questions the aim equation. That what is that equation which we have to, for which we have to find the enthalpy. So here is enthalpy of formation. So what is getting formed? CH4 is getting formed. Now how CH4 gaseous will be formed? Just take the elemental states of carbon and hydrogen. So carbon exists as C in solid form, and there along with this there will be hydrogen, which is having an atomicity of 2. Since hydrogen here at the product side is 4, so there will be, on balancing, we will get 2 moles of hydrogen. Now our equation is balanced also. This equation is balanced also, and this is our aim equation, right? Now let us see what are the values that are and equations that are given to us in an indirect form. So firstly, we are given with enthalpy of combustion of methane. So note down that if they are providing you with enthalpy of combustion means that you have to react the particular thing with oxygen. So firstly we are given with enthalpy of combustion of methane. So this is methane CH4 plus, we have to do combustion of this CH4 plus O2. So hydrocarbons on having combustion gives CO2 and H2O. Hydrocarbons on combustion gives CO2 and H2O. So alkane. So methane is an alkane. On balancing this equation, you can balance it on your own on the basics of class 10th which you have. So this becomes 2O2, and on the right hand side this will become 2H2O. Now I think that hydrogens, carbon and oxygen are all balanced. We are given with the enthalpy of combustion of this, and the symbol for enthalpy of combustion is del Hc, which is minus 890.3. This is given. Next is the enthalpy of combustion for graphite. Now graphite is an allotrope of carbon, so this is carbon itself, and on doing combustion of carbon we will get C plus O2, which will give us CO2. Now enthalpy of combustion of this is also given to us, which is minus 393.5. And the next thing is dihydrogen. The third thing that is given to us is dihydrogen. So let us do the combustion of this also, and H2 plus O2 will give us H2O. So on balancing it, we will get 2H2 plus O2 will give 2H2O. Now you can see that all hydrogens and oxygen are balanced, and enthalpy of combustion of this is also given, which is 285.8. So this is our first equation, this is our second equation, this is our third equation, and this is our aim equation. Now using these three equations which we have reduced using the details which were given in the question, we have to make the aim equation. So as you can see that in the aim equation, carbon is written on the left hand side and hydrogen is written on the left hand side. CH4 is written on the right hand side. Now in the first equation, in this first equation, you can see that CH4 is written here in the left hand side, but you need it on the right hand side in the aim equation. Also, 1 mole of CH4 is needed in the aim equation, and 1 mole of CH4 is given in the first equation. So you just have to take the first equation, which should be multiplied by 1 only, because only 1 mole is required and 1 mole is given. But given side is left and the aim side is on right. So we have to multiply it with minus sign also. because left right का थोड़ा सा इसमें issue है. Now the next thing is carbon is written on the left hand side. In the second equation, you can see that carbon is written on the left hand side. So 1 mole is required and 1 mole is only given. So these things are same. So plus sign will be used because both are on the left hand side, which we aim for and which is given. And 1 mole is required. So just multiply the second equation with 1. Also 2H2 is given here. Okay. So you can see that 2H2 is required, and actually the dihydrogen, combustion of dihydrogen was given here. So dihydrogen is basically only H2, but on balancing you have used 2 moles of H2. So you have to keep in mind this thing, or you may write this equation in this form also. H2 plus half of O2 gives H2O. So this also can clear all your doubts that this is basically an equation for 1 mole of H2O, combustion equation for 1 mole of H2O. You can use the third equation, this equation also, but you must be clear in the fact that these two has came from balancing, but they were asking, they have given you the value which is 285.8 for only 1 mole of dihydrogen. Out of balancing we have reduced the 2, so you have to multiply 2 with the equation number 3. Also H2 is written on the left hand side in the aim equation and on left hand side in the given equation also. So plus sign can be given to it, but 2 has to be multiplied in the third equation, which I am repeating again and again, that the combustion value of dihydrogen has been given to you, not of 2 moles of dihydrogen. It is this 2 has just arrived due to balancing, so you have to multiply it with 2. Now you just have to solve this. So just you are having the values of all these 3 equations, like second equation multiplied by 1 will give you minus 393.5. Second equation multiplied by 1. Okay, now third equation multiplied by 2. Third equation is also in negative sign. Let me write it again. Third equation is also in negative sign because these all are enthalpies of combustion. So this is minus 285.8, which will be multiplied by 2. So this is second equation and third equation, and minus we have to do with first equation. First equation is minus 890.3. On solving all these 3 equations, we will get the answer of about minus 74.8 in kilojoule per mole units, and hence this will be our answer. So the basic gist of this question or these types of questions will be whatever the information is provided to you, you just have to write the equations first and you have to write the aim equation. Now you have to see what things are written on the left and what things are needed on the left. Similarly for the right hand side, if thing is written on the left in the reduced equation and in the aim equation also it is written on the left side, then you have to take it in positive sign, otherwise you have to apply a negative sign. Okay, and then you have to compare the number of moles, as I said in the third equation, that for how many moles the value has been given in the question. Since the equation the values here are given for 1 mole only, so if there are 2 moles that come out due to stoichiometric values, then you have to multiply the given value of energy with 2 also, and then you have to apply the same thing in their energy values also to get the energy for the aim equation. Okay, so this is an important question which can come in your final exams of school level. Okay, thanks for watching. Thank you.